on, I'll go ahead into multi-guest, and then, yeah, I'll invite settings from followers only. Okay, folks are joining. All right, and invite. I'm gonna. It says no viewers or friends to invite. I think you have to join the live. So in order to get an invite, but yeah. And yeah, okay, cool. There's Joaquin. Hey, Joaquin. I'll invite you to multi-guest. And then you'll probably want to drop out of gather. Cool, alright, I invited you. And there's other people. Alright, hello everyone, hello. Thank you for coming. We are doing robots today. There's Joaquin. Alright. You probably want to, drop out of gather town. But other than that, we're here. Okay, we're gonna do some robot stuff. Good to see you. Alright. So we're waiting for Andy to get here. Joaquin's here. Joaquin is the designer and builder of the Rover, and also the code that controls the Rover. And what we're doing today is we're going to try to put an AI into the Rover. Basically, we're using ChatGPT 4.0 Mini right now, and we'll probably eventually break off into some other more like, open source AIs. So, let's see. Let me know how. Can everybody hear me? Can folks hear me? Just checking in, making sure.
I hear you double.
Oh, great. Yeah, you want to get out of Gather Town.
But it could be
me. Leave Gather Town. Joaquin, you're still here in Gather Town. Does that make sense over here? Yeah, there you go. Cool. All right. Am I just one person now? One voice? Cool.
No, you're still two voices on TikTok.
Oh, I'm two voices on TikTok? Okay. Let me look at that. Sorry. Alright. That's weird. Alright, let me, I'm gonna leave Gather for a minute and see if that will help. Okay. So, let me look at the scenes. Let's see. Am I still two voices somehow? Anybody? Can y'all hear me good? I don't know.
For me, you are, but maybe it's just me.
Yeah, I don't know. Maybe it is you, but I feel like I should somehow know. The sound seems like it's like no longer. I don't seem to be able to. Oh, that it does look like there's two. Okay. All right. Delete audio. Yeah. Okay. There were two audio devices. Great. All right. We're here. And we have one audio device. All right. Let me go back in together. Cool. Yeah. Cool. Just logging in to the rest of my team. The crew up at the Multiverse school. They are a bunch of researchers and computer scientists and folks who have been helping me keep up with the stuff. So these are the crew. Hold on, and I'll be able to show it to you. There we go. Yeah. Okay. I think. No, that second one is a different thing. Okay. I'll delete that and add the gather time. We're still waiting for Andy and some other folks to join in too. So that's the there we go. Add source. Cool. All right, we got gather town. It's hard to see, but we got it. Let's fix that. Get rid of the chat. This chat specifically. No chat. And then we'll go into meeting mode so y'all can see their wonderful faces. Okay, cool. So anyway, so we've got Joaquin here, and Joaquin is the builder of the robot. Say hey, Joaquin. Also, we can't see your video, so.
Hey.
Good.
Oh.
Yeah. I think you have to like give it video again. You might have to like add your camera or something like that. So yeah, if you're just joining us and you didn't come to the last one, we've got quite a few things. Let me kind of give you an idea of what we're doing here. So we've got this agent, and the agent will, it has like, it can see, it has a video capture. We connect to OpenAI, and then we connect to MQTT, which is a message queuing server, kind of like RabbitMQ or Redis if you're familiar with any of that. And then we've got frames from, we can capture frames from the video stream, so we can use that to see. And so then we go through what's known as the OODA loop, the observe, orient, decide, act. And so that is, like, observe is go get a camera frame and then upload it to OpenAI, and then it gets a visual response. And then from that, what we do is we orient ourselves against maybe our goals. We haven't really put a lot in the orient step. Really all we're trying to do is get it to like navigate around and do stuff. And then we use decide to figure out like what are the options that you have. And so it will respond with one of these strings, and that will cause us to send an action specifically to the client. And we do that by publishing to the MQTT server. And then we've got, this just runs once a second, basically. And so, yeah, and then here's where we're like uploading things to OpenAI. So it's a pretty simple agent. It's not a lot of lines of code. You know, it's less than 200 lines of code, and we can control this rover, mostly because there's a lot of logic over here on the rover side. But even the rover is still, this is like the you know, TikTok client, but we base the rover on that. And let's see, the actual rover, let's see, Adreno code with RoboClaw. Yeah, this is the actual code that really runs the rover itself. And so again, not infinity code, less than 350. So here's the RoboClaw. Yeah, that's generally what we're doing. We're trying to figure some stuff out live on stream, partly just so that everyone can like see the process of figuring things out, and so that y'all can help and give me your ideas and stuff like that. You know, I'd love to know what you think about this process and this project, and we would love some silliness from you. So yeah, that's what we're doing today. Currently, the plans that we have, we had maybe stuff like a temperature sensor that looks for abnormal readings, camera motion, search for objects, crawl the space and find things, or like let Twitch chat tell the rover what to do, which sounds fun, and I think we could do that too. So if anybody's down or to just hang out and watch us work through this stuff, that's essentially what we're doing. So yeah, love your thoughts. Joaquin, do you want to let's see, is the rover up right now?
It is up.
Okay, cool.
Yeah.
All right. cool. This is the scene. I'm not sure. Let's see.
Oh, it's not up.
Oh, is it not up? Okay, cool. All right. Let's see. I am gonna try to run the rover. I think we still have. Let's see. Add source. Let's see. I am gonna try to run the rover. I think we still have. Let's see. Add source. Did that just go down? No. Okay, we're back. All right. Internet was being a little weird. Okay, so yeah, I dropped a link in the chat for the repo that we're working on right now. And now this has done the thing, so source environment, great. I'm gonna move these up. Okay, so we haven't super organized this thing very, we've organized it to a degree, but yeah, we just have encoding of images up here randomly. Oh, hey, Andy's here. Hey, Andy. I just invited you to join us. All right, everyone. Andy's joining. Hooray. Hey, Andy. What's up?
He's here.
You're here.
Yay.
Yay. Yeah, so I was just kind of telling everyone what we were up to. We got the rover a little bit like working to get images, so now I really just want to say, okay, let's see, Python rover agent.py. So yeah, we got the camera up and running. Okay, what do we got? All right, captured frame. So we've captured a frame. Here's the frame. There's the robot. All right, there's some maybe a cat. I'm not totally sure. Okay, so yeah. So the AI.
Quick note. I'm seeing Joaquin's video is like the main focus.
Oh, okay. Yeah. How do I undo that? I'm not sure if that's. Are you like pinned or something? Shrink. Okay.
I don't know if yeah. Oh, there you go.
Okay.
Fixed.
It's shrink apparently. So. Cool. Yeah. Well, thanks for coming, Andy. So, yeah, we got the rover to take an image. So we've got this image, and it worked to an extent, but then we got unable to open stream. So it seems like we need to we open the stream, but it doesn't stay open. I guess possibly does it. Oh yeah. Okay. I think we don't want that. That's what was happening as I was releasing the video capture object. And we don't need to do that. So I'm just gonna try it again. Sorry, I'm realizing I did need that thing. I needed part of it.
All right, it's working.
Cool. Okay, great. I'm gonna try again. Get that up.
Maybe mute the video stream.
The video stream?
Yeah, the one coming from the robot.
Oh, I don't think we're getting anything. Okay, it says video capture died. Alright, why did the video capture die? Exception is E. Print E. Oh, you know what? Maybe the video capture didn't die. Okay. Let me try that again. Okay, cool. Here's what it's seeing now. Alright. Here's what it's seeing now again. Okay. It's moving. Oh my gosh. Y'all, it's moving. It's capturing a frame. This is excellent. So it just says go forward. Yeah, it's moving. It's a little slow, but it's moving. Yeah. Okay. Well, that's pretty delightful. Do you want to share the rovers, like, over TikTok Live or something like that, Joaquin? If you want to share your screen, or yeah, the stream from the rovers, like, it's going. If we actually just keep rover.jpg open, it will kind of be a stream. It's only capturing a stream every like second, but it looks like it's moving a little bit. Yeah, it's like inching forward. So yeah.
Or maybe even like a third-party view from Joaquin's phone.
Oh yeah, that seems cool.
Because I think you're TikTok living from a different phone, Joaquin, right? The one that's an avatar.
I'm living from my only phone.
Oh yeah.
Oh, so the Rover doesn't have a phone on it.
No, it has the GoPro.
Oh, okay. Do you want to turn on your video, Joaquin, and show us the rover?
Yeah, it says that. I think you need to give me permission to have video.
Oh no.
You just hit your own video and you turn on the little camera button.
In TikTok, not on Gather.
Mm-hmm. You should hop out of Gather, Joaquin, I think it's where your double audio is coming from.
Yeah.
My computer is completely muted.
No.
Are you on so you're on your phone though, right now? On TikTok, right?
Yes.
Okay, great. So, you should have like a start video button. Right now, your video is just like not on. It might be like, yeah, if I open up, yeah, you should have, it says I can't invite you to turn on your camera. So, I think you have to like click a button of some kind. I'm not totally sure.
Alright.
Hold on. Oh, okay, that's not. I'm gonna shrink your video again. There we go. Okay, cool. Yeah. Well, so far, I mean, it looks like it is moving. It does look like it's stuck somehow, though. So it might not be receiving messages. Like, I can tell the visuals are changing. But, yeah, it seems like it's not quite.
Yeah, I don't see any more traffic on the MQTT.
Yeah, is it, so it's just not receiving anything?
No, if I send the message here,
Let me see if it'll.
it will move.
Okay, let me see. All right. Hey everyone. Okay, so. Yeah. All right. So it should. Is it not able to capture or get? Okay, wait. Yeah. It's saying that it's sending a forward message. Are you getting anything from there? Oh, we lost Joaquin. There we go. All right. That might have been what was up.
I think he's refreshing data permissions for camera.
Yeah, sounds good.
He has it locked down.
Cool. All right.
Technology is hard.
Yeah, it is.
Yeah, I don't see anything on the broker.
Okay, so let's look at the broker. Or let's look at the thing. Right, we keep capturing frames. That's working. We say, okay, please interpret what the vision model says. And then we do a decide, and then we do act. So it's observe. Observe doesn't take anything, but it returns an observation. and that's the environment data. And then we pass that to the orient function, which gives us an orientation. And are we in the agent step? Are we logging everything that we're getting? Yeah, we are. So it doesn't look like it's actually always getting the data up there. It like moves for the first one, but doesn't move for the second thing. Like, let me know if you're getting anything. Okay. And so then it says right. So it used right, which should have sent. So it should have gotten like forward or right. And you didn't get anything?
No.
Okay. Let me just make sure that it is connecting. Client equals mqtt.client. All right, maybe it's that. No, I mean, it was just working like a minute ago. And this is the timeout. Do you get any, do you get anything from when we connect? Like, have you received anything in the last few minutes? Joaquin?
No, nothing.
Nothing? Okay. So, are you sure that we did, in fact, get like the same IP address? Because I know you rebooted the Linode. So, are you sure that we're on the same IP that we were on before?
Yes, 139.
139? Okay. Okay. So let me just check. Sorry, I'm trying to like put this in front. Bring forward. Bring forward. I'm just gonna like bring to front. There we go. Just gonna obscure clicking on the environment thing real quick. Okay, hold on. Let's do it. Okay, and so the MQTT server starts with, or it ends with 139. You said
Correct.
on port 1883, the normal one. Okay.
Yes.
All right. So it seems like we're probably connected to it then. Let me make sure. Okay. Source IMD. All right. Rover Python. Rover agent. Okay, it got the thing, and then it said forward. And now it's saying forward, and now it's saying go. So, is it, and it's on the action topic.
Yeah, no, I'm not seeing anything.
Okay.
Is the username and password okay?
Let me check. I don't think that there is a username and password on here. So that is probably part of it. Did we have a username and password before? Was it like?
Yes.
Okay.
I sent you an email with the info.
All right. That explains a lot. All right, hold on. And that's for MQTT specifically?
Yes.
Okay, I'm just gonna pull it up over here. And Joaquin, yeah, there we go. Okay. That's Mona server. Joaquin.
Oh, it doesn't.
Okay, and then how do I? Okay, MQTT user, MQTT password. I see. Okay, equal. Let me just make sure that I'm not. Or oh yeah, okay. Word. I'm pretty sure the rover, yeah, MQTT user, MQTT password. Yeah, I think I definitely lost that somehow. Okay, cool. All right, so just making sure that nobody can see those things. Yes. Okay, great. Okay, now I just gotta get them from here. Equals great. Okay. Now I can put these here. And that'll do it. Okay, great. Now I'll go back to TikTok and move this little window here. Great. Okay. Now start them up again. All right. Is it moving? Oh, lost Joaquin. All right. No? Oh, no. Cool. Okay. All right, y'all. We are cooking with gas. Is it moving?
No.
No? No. Okay. Are you getting any response though? You know what? I might not have done so.
No.
Try once more. Oh,
Yes!
Hey, it's working. All right, now it's moving. Nope, that's not it. It's rover.jpg. Okay. Captured frame. It's turning left. Is it turning left?
Oh, yeah.
Okay. JPEG. Is it working? All right. Did you figure out how to show us your camera?
No.
No, you didn't figure it out. Okay. You want to try that? It would be cool to watch it move. Let's see. Yeah, you're out of gather. Oh, I lost him. Okay. He'll come back. Yeah, I don't know. Like, all right, cool. Well, we've got a rover, and it is updating. It seems like something's up with the flow. So while we're waiting for, is Joaquin back? No. Nothing. All right, we're catching the frames. So I'm gonna debug some of the things that are weird. It seems like it's not necessarily always doing the observation. And so I'm just gonna print observation, and then I'm going to print orientation, and then I'm gonna print the decision. ChatGPT has me covered. Okay. And then the action. And then, yeah. So I'm gonna shut that down, start it back up again. And let me see if anybody, let's see, did we get, nope, okay. Still waiting, all right. Mostly dark, maintain a positive attitude. The unique design of the rover can play a role in its operations, encouraging maintain a positive attitude. That's its goal. Let's see. Yeah, it looks like it's okay. So it is sending like actions, sending the, so okay. I think it is doing what it's trying to figure out. It's like trying to back up because it's maybe in a dark place, right? It's like, I see a mostly dark environment with a faint reflection indicating a flat surface. The rover appears to have googly eyes and a colorful heart sticker on its front. There are no visible obstacles in close proximity, but the space appears quite confined. And then it says, I recommend moving forward cautiously for about 10 centimeters. And so we're just giving it, one movement per frame and one frame per session. And I think when we do this, we have to wait for the response, and when we do this and we send the actual image up to OpenAI, we have to wait for the response. And so it's like, that's the rate limiting, right, that it's doing. So it's not able to fully, it's doing a full conversation with OpenAI every single time we get one new frame. So what's it seeing? Okay. So it needs to go backwards. Okay. Are we getting a new frame? Okay. Yeah, looks like, okay, so it's not showing up back up. Let's see. Let's see if I can invite Joaquin by clicking on this. Okay. Alright. I don't know. Alright. Well, there's a rover out there, and there's Joaquin out there somewhere in the world. And this is the rover that we have working. So it's trying to back up because it can tell that it's run into this thing. And it's not able to actually get it to move, right? Because I think we've lost connection somehow. Either that or we've lost connection to the rover's back end. So it's possible that oh wait, no, we're back. There's Joaquin adjusting the rover. Okay, so slow down, engage with obstacles, and now it's trying to move forward. And Joaquin's adjusting the rainbow thing, so that's pretty great. I wonder if it's trying to move forward while Joaquin is adjusting it, so that's pretty great. But yeah, so this is excellent. Proceed with cautious forward motion. That's wonderful. So the GoPro is still transmitting, but we're clearly disconnected. It's telling the rover to go forward, but the rover's not receiving our commands. If you just joined us, just to kind of give you an idea of what's actually happening with the rover itself, we've got, this used to be a rover that could be, controlled by TikTok Live, right? There's a cat. And so you could get a bunch of commands, and it would move left or right and things like that. But TikTok Live, just as a group, it's hard to get coherent motion out of that. So we were like, hey, what if we put an AI in the rover? There's Joaquin doing something. Manipulating the rover. There's Joaquin is joined again. Multi-guest. All right. Anyway, so this is the actual rover's code, and it's got some action delays, And really, it's just listening to receive a command. So we could send it a lot of commands really fast. But really, we're only sending a few, like one command at a time, just like one movement. So what it's doing, what the agent does, is it executes what's known as an OODA loop. Like, you learn this if you go to basic training. And it's like observe, orient, decide, act. And that's kind of like, that's what you do in the world. So you're just walking around observing, orienting, deciding, acting. That's what we do. And so, you know, they developed this and taught it to people so that they could like get out of a freeze response, really, to be like, okay, I'm freezing, observe, orient, decide, act, you know. But it's actually like a very good framework for agency. And so if you want to give an AI the ability to go and do stuff and make decisions and try things, you have to kind of manually code that agency in, because it's really just a language model, right? So that's what we are doing, is we are trying to put a large language model inside of this rover. We've got Joaquin, who's around and also fixing the rover. And then also Joaquin's cat, who's interested, politely tolerating the rover. And yeah, so they're trying to get it going, and you know, it's not moving, the rover, right now, because it doesn't seem like it's able to hear the commands that we're sending. I don't know if we've actually connected, but I think zaniness, like ideas, it's definitely super fun. This is kind of the like experimentation that we get up to here at the Multiverse School. We like to hack things together, and Andy is, of course, a well-known prolific hacker of things together. So it's pretty fun. You want to talk about the rover and all this stuff?
Hacker and slasher. Yeah, I tell people that we're like junk farmers. Yeah, the rover is an interesting project. It's something that came together because we wanted to show the public the inside of the car factory, and we wanted the audience to be able to drive it. And we were like, well, do we have like turns, or do you like go to a website? And I was like, no, it just has to be so easy through Stream. And so it originally was the penny gifts, so that you could drive it and not like have it get griefed. Someone just sent like a million forward commands. Mm-hmm. But then it was so popular that really nobody can grief it, because there's so many commands. It's really so chaotic. And the motivation behind adding like a LLM or an AI to it was like, can we make some sense out of all that chaos? Like, what's the average of everybody's, or what's the true intent? Or can John have an opinion about where he's been told to go? Maybe he just still drives crazy, but he has feelings for what you made him do.
Yeah.
He is named John because there used to be a lawnmower from this Nate, who was a homesteader, that was named Hank. And I follow Hank and John Green, and we named the robot John. And Hank liked it on TikTok, which feels like winning a Grammy, or a Golden Globe or something.
Yeah, exactly. True. Yeah. It's a cool way to do stuff. You know, just live, and like just let's sit down and make it, and like try and see what we can get going, and see if we can, you know, and just like and play with it. Like, I feel like a lot of the maker culture is about just playing with things and just being like, what can we get it to? Okay, now what's the next thing? And we like short, tiny little goals of like, can we just get it to dance to, you know, hot to go, something like that. That was great.
Yeah, if we like sat down and tried to make like a great robot, we would have never gotten any part of it done whatsoever. But we were like, let's start with a terrible one that has zero awareness of where it's at, zero awareness of what it's being told to do, and it's just like, let's just physically limit it from being able to like really do damage. Then great, we had it running like very quickly, and we've iterated our way towards something that runs very well. And for reference, this that you're seeing on the video audience, is like a small tabletop version that we use for like testing and development because it's super light and easy, and we get to troubleshoot like MQTT flows and whatever like this. The actual John is like a much bigger commercial robot that will bring this learning into. And so on future lives, you should get to see a giant commercial robot ran by the team's code.
Yeah. I'm really excited about that. I have a lot of cool ideas. I mean, honestly, stuff like an inventory robot, or just like, where did I leave the spot welder? In this 4,000 square feet or whatever. I think
being able to like search your place even without you having to automatically categorize it would be wild. Like if it just drove around once in a while and like identified objects and like physical location,
that would be huge.
I wonder if it could use like that interior beacon thing, which is like not GPS, but it's like GPS for indoor spaces.
Yeah, we were kind of kicking around that idea last night while we were trying to get the video to work. And I was going to ask you about if you've played with anything like that, because I haven't really personally.
Yeah, there's like these millimeter sensitive indoor things that use like a couple cheap beacons, and then you move the device around and it goes, oh, okay, cool, I'm like here. It's really for like museums and all that. And I guess it runs on NFC. And so like your phone does it automatically in like dense spaces like airports and stuff. It knows these beacons. So there must be an easy way to do it.
Yeah, there must be something. All right. Interior navigation.
Yeah, here's a paper. I'll drop it in and gather. But I know this has become like kind of a standard. I just don't know what they call. Oh, here you go. Instructables. You can use RFID tags.
Great.
Neat.
RFID tags. Okay. Yeah, actually, RFID tags would be just as beacons.
Mm-hmm. And so it helps rectify its like internal navigational stuff by being like, oh, I'm near that. Great.
Yeah. Okay. RFID NFC tags. Okay. With a grid pattern on the ground. Okay, so it just knows.
Oh, that's like super dense. Yeah, I'm talking about something that uses like a few.
That's like. So, I mean, yeah, here's I have
Tomo ID. Scalable indoor scalable approach to device-free RFID internal navigation.
So this is, I mean, you don't need that many, is the thing.
No.
You don't, like, this is like millimeters, like this is like 15 centimeters apart, You could do like 200, and just if you knew where in a grid of like 200 different squares like a tool or something was, that would be huge, right? If you could just tag objects to 200 possible points that they could be, or 500 or something like that. So yeah, where are we at? I wonder if Joaquin will ever come back. That would be cool.
I'll send him a text.
Yeah, that might be helpful. Yeah, Laura is, it's so funny. Like Laura, Laura, not AI Laura, but Laura, low range, or low frequency, I don't remember what it actually stands for, but it's like the radio thing. Yeah. from.
Apparently,
Lawrence.
Joaquin is trying to get back in, but it's sending some kind of permission to you to ask.
Okay. All right.
Maybe it's back in the TikTok client. TikTok is so annoying.
Yeah, the client is not the easiest thing on earth to use. Okay, multi-guest. Oh, there's a new request. I see it. Okay. Show me. Accept. Great. Okay, I've accepted. Hello, Joaquin.
Yeah,
Hello, you're back.
He's back.
I'm so happy to be back.
How's the Rover?
Well, it's exploring my toilet.
Okay.
If you connect through VLC on your computer, you'll have a live stream.
Oh yeah, you know what? I was gonna do that. I actually don't think I have VLC on my Windows, but I can download it very quickly. VLC, the best media player. VLC. Download. Okay. No. I'm not gonna. Okay. Open that. Alright, do it. Install it. Yes. 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 Okay, next. Wait. Yes. No. Okay, cool. I knew there was one sneaky one in there. Okay, cool. Okay. So it says unable to fetch frame. Wait, cancel. Alright. It looks like it lost connection, so we'll go back to rover.jpg. Oh, there it is. Exploring your toilet. Okay. Great. Okay, so I wonder if it's, oh, it says forward. Why? Backward. Okay. Is it moving?
It is.
Great. Okay. Yeah, it takes a second. Alright. Let's look. Oh, sorry. Okay, so I got this. Is it done? Finish. Cancel. Continue. Alright, and I know that I got one thing over here. The RMTP server. Okay. Media. Network stream. Paste this in. Play. Okay. Alright, we're connected. Wonderful. Audio. Good. Cool. Okay, let me get this on the thing. Scenes. Add source. You're gonna love it. Okay, window capture. And there we go. Okay, cool. Check this out. Oh my gosh, y'all. The Rover. It's doing it. It's trying to get out of the bathroom.
Oh my gosh. This is the moment.
This is it. It's doing it. It's like escaping the bathroom. This is excellent. I'm very, very excited.
It would be really cool to have an on-screen display of its own internal thoughts.
Oh yeah, we've got them coming in. It's like move forward. You know. Oh. It's great.
Because it has like really poetic, like internal communications with itself.
Right, it does. Let's see. Let's look at what it's saying. We got stuff like the rover is positioned inside. To proceed, it should consider moving backward. I see a small, colorful rover facing a large white curved surface. Is it perhaps not actually saving the thing because we potentially have it?
Like a context memory?
Yeah, it doesn't.
Or the image.
It's not connected. Okay, part of it is this. It's not actually connected. It lost its little. Like it was capturing frames, but yeah, it had lost connection. Okay. Great.
So it was processing the same .jpeg.
Yeah, exactly.
I wonder if the custom instruction should include ignoring the rover itself.
It's possible.
Because I think it's perceiving itself. It sounds like. Wow, that's deep.
It is. Okay, so we should do that. So I'll sort of get in here and what do you see? Your response should help the next agent to generate the next move for the rover you're writing on. So let's see. You are a rover. A friendly, playful rover. What do you see? Okay, cool. All right, so there's that.
Maybe like your point of view is third person or something.
Your point of view is third person. What do you see? The next agent. Okay, cool. All right, so now let's watch it. What do we got? Cheerful rover sees. Okay, so now it's talking in the third person. The cheerful rover is in a cozy environment. Okay. Your visual point of view is third person, but please think out loud in the first person. So it says like I see. What do we got? How's it doing? Oh, no. Okay. What do we got? What more? What delightful adventures. Okay, be backwards. Excellent. Do it. Alright. Oh, no, it says forward. Okay. So its navigation is, you know, alright. So, please interpret what the vision model saw and give a description of the plan for what to do next. Try to avoid getting stuck in corners. Alright. Now, let's see what that does. Alright. Now you're stuck in a corner. It feels a bit snug.
Diode the cat does not like it.
Yeah. I can hear the cat. Oh! Turned really good there. Oh, a cat. Okay. This is great. This is literally the best. This cat. What does it think? Oh, I think it's lost access to the visual feed. Yeah, okay. Yeah, go straight. Okay. Did we lose access? Yeah. Cat cat tree, playful kitty. Okay, this is pretty great. It does look like it's moving the frame. Okay. The capture frames from stream. Okay. I'm gonna save the last camera frame as like the most recent thing. So, okay. So like, change the name of rover.jpg to, or like, yeah, hold on, okay. Let's see, I'm wanting there to be like a bunch of earlier frames, and I want them to go in an order, right? So to the current timestamp in the slash old frames directory. The current, not change the name of, but like move current timestamp .jpg in the old frames directory. No. There we go. Okay. Alright, old frame. OS.rename. Okay, cool. And then we'll make a folder, old frames. Cool. Alright, now it's in there, and then we can write. Let's see if that works. Old frames. Cool. Oops. Old frames. Alright. Alright. It's doing it. Hooray. Okay, cool. So now that we've got the frames, wait, why does it say I can't move through the door? I can't move forward through the door. Why not? Why does it think that? Oh, because the door's closed. Okay, cool. Rover.jpg. It doesn't look like it's actually moving, but let's see. Oh, yeah. Did we lose this? Hold on. Okay. I tell you what, I think that there's no reconnect logic in here. So, let's see. So let's do this. Let's put this in reconnect. Okay, wait. Stream URL self.stream URL. Equals stream URL. Okay. Self dot stream URL. Now it will try to reconnect if we lose it. Okay. Alright. Now we're here. Living room. Great. Alright. Let's see if it's moving.
Hey, Liz.
Hey, what's up?
I think the TikTok streams OBS scene is all screwed up.
Is it?
It's like off center. There's a bunch.
It looks okay to me.
Profile. Wait, really? Oh, okay.
Mm-hmm. Yep. I'm seeing some
I don't know
code.
what
I'm
I'm
seeing
seeing.
Liz. I'm seeing the Rover in a VLC window.
You're on.
I'm on desktop. I don't know if that changes it.
Yeah, that might be. But I'm gonna take a look. Someone says, yeah, it's over. No. Nope.
Music.
Okay. Yeah, that looks good for me. I don't know.
All right, never mind.
Thank you for telling me though. It looked weird. Cool. All right. Well, it does look like we're moving around. But it also seems like, yeah, it seems like it's like losing access to the camera, or it doesn't always know how to like back up and turn around. It does also seem like we need some memory, so I'm gonna kind of write some things down up here. Let's see, couple things. Okay, so rover improvements. So we've got the vision system, right? And the vision system has some stuff in it. It just naively just captures an image and sends it to OpenAI. You know, that's it's really simple. And so I think like the next step is get the image capture to send to cheaper vision classifier models that can run on small consumer hardware, so that we can do stuff like just get it running on a PC somewhere. And so if we could do something like, you know, get the image capture to set to catalog images, or not catalog images, but like identify objects. So there's that we could get it to do, and save those somehow. And then we've also got like mapping and telemetry, and we need like indoor navigation through beacons. And then what else? We also right now there's like navigation. Right now we're just sending one movement at a time, right? And so like, go get the cat, that's the best. I see a cozy living room. Oh no, it has definitely stopped seeing things. Do you see the cat? Yes. Alright, what do you think when you see the cat? Slowly roll forward towards the kitty. After checking in with the kitty, you can assess whether to continue. Let's move towards the cat. Alright, how's this gonna go? Alright, I just want to watch this part. What's gonna happen? Cautiously.
Will it run over the cats?
I mean, just cautiously approaching slowly. The cat's like flicking the tail a little bit more. I should be careful not to startle it. Okay. This cat is used to this rover, you can tell.
No, yeah, this rover is not the weirdest thing this cat have ever seen. By following these steps, you'll not only enjoy following the cat, but you can also... That's great. Alright, so I can see that it can't see the cat. Like, yeah, okay. So it's capturing a thing, but it like definitely loses the cat, or it loses the thing after a minute. And then so I'm not sure what's going on with that, so we're probably gonna have to figure that out. Like, seems to lose the feed, perhaps needs to do something else with the feed. I think we're handling this in a very naive way. We're just like, capture a random frame, and then it writes it to a thing. So, I think, yeah, like, here's where it thinks it is now, but then it doesn't necessarily always change. Yeah. So, I can kind of see, like, okay, the old frame. Yeah, and it's just saving the old frame. You can kind of see that it hasn't really, like, actually changed in a minute. So, where did it actually end up? Yeah, see, now it's in the room with the cat thing. So, I think what we're going to have to do is debug that. I'm not totally sure what, you know, what is happening there and why the frame is not, like, actually doing anything. We could try just doing the... If it's, like, reconnecting to the stream every single time, is that going to be an over... until it's... yeah, sorry, I'm just checking in. Is that going to be too much if it, like, reconnects every time? I'm really not sure why the stream dies.
No, it was doing that yesterday, and it wasn't a problem.
It wasn't a problem? Okay.
No, the server is happy.
Okay, great. Well, then I am going to put this in here. And then I'm going to do self f.stream URL, and then we could basically finally, you know, okay, and then I could just say finally do these things. And then I only want this to show up here. Okay, cool. And then there's, I mean, maybe this also. And then it reinitializes. Yeah, let's try that and see if it doesn't break. Unsupported AMF type. I don't know what that is. Okay, let's see. Is it doing it? Alright. No, it's definitely... Oh no, it did change it. Okay. That does seem a little bit more robust. Let's see. Roll towards the door and see what's beyond it. Okay, okay. So it's able to, like, oh, it really knows how to, like, turn right. Oh, interesting. Okay. So it really does know how to work out where it's what it can do next, you know. So I'm pretty okay. So that seems to have fixed the problem with the not being able to update its visuals, because it's able to, like, actually move around now. Okay, so that's cool.
Yeah,
right.
the traffic on the server looks way more active now.
Yeah, it must not have been recapturing a new thing every time. Yeah. Okay, so that's good. It's, yeah, exactly. Okay. So now, yeah, it's gonna go explore your bathroom again. Align to the left wall and prepare to turn right. Okay. All right, so the next thing is to add memory, like maybe there's a goal. And so most of the time, if you're going to have a goal, you want to put that in like the Orient part, right? And so what we could do is there's a lot of messages. I guess it does have the previous messages. It does actually have a memory because it has stuff in the messages. In terms of the agent step, like we should probably not send all the images or all the messages every single time. So like, you know, maybe. Well, actually, it just has a really big conversation context, so I guess it's okay. Maybe I'll print then messages. Messages in context. So I can kind of see what that looks like. Okay, so there's just like not a lot of messages in context. Okay, we captured a frame. Four messages in context. 7 messages in context. Okay, so it's like accruing messages. So it should have a recent history. And it should be able to set goals, essentially. Because it has all the previous things. Then I can like, it says next move, let's back up a bit, backwards. Then I can see if I can turn and explore around the cabinet. What do you think? And then the backward, and then it kind of goes backward and left. So it does seem like it followed its plan. And it does seem like it's able to, yeah, curiously wander around and very cute. It's very cute. So let me see if I can kind of add in a list of items. Let's say just sort of like list of found items. Items equals this list, and then like found items file path equals found items.json. Great. Okay. So whenever we capture a file from the stream and we do an observation, I can say, okay, you're a friendly, playful rover. Your visual point of view is third person, but please think out loud in the first person. What do you see? Please also make a list of all objects that you see. That you see for inventory purposes, so that it knows what it is that we're trying to get lists of. Okay, so we've told it to do that, but now we need to like extract that information somehow. So I'm just gonna say that we have a function called extract items, and we'll pass in the observation. Now we don't have that function yet, so I'm just gonna go up here and say, okay, def extract items. Send a call to OpenAI to extract the items from the observation, then save the items to a file. Great, that's exactly what I want. Okay. Item, like, the observation's what's passed in, so response equals OpenAI. Let's see if it can. Okay, cool. Alright, so I'm gonna give it a system message here. Roll system, system, and then content. Items listed from the observation to so we can keep track of these items in inventory. Reply as a list of items. Reply with JSON? Yeah, reply as a list of items. Reply with JSON. Okay. And then response format. Is it response format JSON? Let's look at the docs real quick. They change. Platform.openai.com. Docs. Cool. Alright, we need chat completions, response format. No, I mean, what I want is JSON responses. Tools, chat completions, overview, getting started. How do I ask for JSON? JSON mode, okay. So, response format JSON object, great. Okay, I could go back up here and say response format JSON object. Okay. Items. We'll print the items and then we will append them. Hold on. .jsonl. We're just gonna use JSON item L so that we can dump all the JSON on one line. And there we go. Okay. So now that extract items from the observation, it's right there. We are using it. Not OpenAI client. Where is it? Yeah, okay. I'm gonna add this now as self.openai. Is it self.openai client? Yeah, underscore client. Cool. All right, now we're gonna put that in the agent. And that's capture frames. There's observe. I'm gonna put it right next to observe because it kind of goes with observing. So, all right, and then tab it over properly. Okay, wonderful. And then we'll do self dot here. And now we've got item extraction. Let's see if that works. Oh. What is the problem here? Line 98. Okay. Oh, I just have a dot at the end. Why? Cool. Great. Light fixture. Okay. So now we have found items. Great. All right. I don't think I have to JSON.dump s. I think I can just, yeah. All right. I think I just do items. There we go. Because it's already text. Cool. Okay. Found items. Smooth textured wall, a wooden surface, an overhead light source. Okay. Cool. Alright, something broke. I don't know. Probably lost access to something. But yeah, okay. So it's found some items. All right, great. So it's able to find items. I'll have to tell it something like, don't list walls and doors and things, just objects. Don't list walls, doors, or other parts of the building. Only objects that would be inventoried in a warehouse, in a, what is it, like garage? I don't know, hacker space.
Super cool factory.
Yeah, super cool. Or maker space. Like tools. Or parts.
Right now, it should list the cat toys.
Or cat toys. Cat or any animals you see. Yeah. Great. Alright, we're also gonna list all items. Or animals, I mean. Okay, cool. I'm gonna get rid of that. Open it back up again. Pink fluffy toy, sparkly pom-pom toy. Alright, oh, this died, alright. Open network. Play. Alright, now we can watch it. Cool. There's Joaquin over there. Okay. We're going forward. Doesn't seem like that was working there. A cat, a furry friend. Alright, cool. Let's look. Found items. Cool. Scratching post. Cat scratching post. Continuing the cat scratching post. Alright. What does it say? Okay. Alright. A list of... Okay. Alright. It's stuck. So, like, you know, I kind of have to tell it. Finish your message with... Actually, sorry, no, that's just the observation thing. I think once we make a decision, please interpret what the vision model saw and give a description of the plan for what to do next. Try to avoid getting stuck in corners. And if you can't seem to roll forward, turn. No? Okay, there we go. Try again. Alright. I wonder how large the images I'm sending over are. I haven't even looked at my usage for a minute there.
I think we lost the GoPro. It's either overheated or run out of battery.
Oh, okay. Yeah, that makes sense. Okay. So it's using the last image, so I want to give it a second to cool down. Kind of talk about what we do next. We did get an inventory robot happening. Somehow in 3 seconds we got a robot that can crawl around and inventory things. Did you see that we did that? I mean, this is the promise of the future, y'all. Okay, so it literally made found items, right? I haven't tried deduping or anything, but it's scratching post with feather attachments, fuzzy animal toy, small yellow ball, cat scratching post, soft plush toy, colorful ball, pink cat toy, right? It's not describing it in a stable manner, but you could figure out that the fluffy mouse toy is the same thing as the plush mouse. Probably also with like llama or something like that. Because llama can tell. And especially if given the old frames and we're like, okay, we found these things while we were out. Now do some real processing of like, what are all the same things? How are all the ways that we described it? And then, like, you know, what actual object does that really map to? So, yeah, I mean, like, we have an inventory robot, you know, in like the most basic way.
You could also save maybe images of said object, and you then have like a visual inventory of a huge space, like
Yeah.
a car factory.
Yeah. That seems useful, right? I would say.
Yeah.
Cool.
Yeah, I'd say.
For I would say 4 hours of total work, that's pretty effective, right?
It's wild.
We live in the future. We do. Yeah, I'm excited. Okay.
If we put one of those dome cameras, those like 360-degree cameras, would the distortion affect the image recognition?
With the distortion, one more time?
Yeah, these like super fish eyes that can be basically half a sphere.
Oh, yeah. Yes. That would give us a lot of visual space, and then we could do 2 of them or whatever, and then honestly you only need 1, but yeah, I would say, let's see, what did this cost me to do today? What is it? It's the 16th. That's from the 9th. Show me today's usage. Today I spent $4, and that was, I sent full quality images. I didn't like scope them down, so I could scope them down to be 512 by 512 and probably have that cost. And we're not using an LM router, which would allow us to use some what's the word that I'm looking for here? Like, so, okay, so there's like an LM router. So we can like route it out to, you know, a local llama or something like that. We could also, we do need to like fix the like logging properly so we can associate images with observations and inventory. Because yeah, we don't have the timestamp on this thing, but if we had the timestamp on it, then it would easily connect any of these individual frames with the timestamp of when it found that object. So yeah, navigation, probably some goals will help. Having direct prompting about the plan would help. We also wanted to do beacons, like if we are available, can tag things locally to beacons. Can also probably do deterministic navigation so that like we don't have to use ChatGPT to visualize everything and make all decisions. You know, because we could use like A Star or something like that to probably navigate throughout the whole workshop. What's the word? Warehouse. There we go. Words are hard. And then I think generally like that's something that's like immediately useful. I don't know, Andy, do you have a tiny rover that you could run at your... Do you have a tiny rover that you could run at your place? Oh, you're muted.
Sorry, the TikTok app is like so hypersensitive it can like hear like a cricket rubbing its legs together. Well, I guess everybody can hear that. A tiny rover here at the today or at the factory soon?
Or at the factory soon.
Yeah, at the factory soon. I can get the real one working.
That could be
You know?
cool. Yeah.
Yeah.
It's a big area to
Like find some
navigate,
motors.
but it's something that we could do.
Yeah.
Yeah.
His motors are $14 a piece. I will get them.
Yay. Okay, cool. That's very reasonable. Yeah, you think we could test out in a very basic way, trying to just make a list of everything we see and like where we saw
Mhm.
it? I think we could do that. It's very reasonable.
Yeah, I thought a lot about how like temperature would affect how it inventories. Like I don't know if maybe a lower or a higher temperature would make a better inventory than with like deduping. It'd be really
Oh.
cool to see the difference.
Yeah, like if we took temperature all the way down so that it was deterministic in the way that it like describes things, so that it's
Mhm.
like fluffy cat toy every time instead of sometimes plush cat toy. Yeah.
Yeah, just like take some of the creativity out of it so that it is a little more normalized.
Yeah.
But maybe there's a critic on the back end that compares the different images and are like, this is the same image.
Yeah.
Goodbye.
Yeah. Yeah, I bet we could use, especially if you tag an image and you say, okay, this is a fluffy mouse or whatever, and then we give it, like, there's several models that we could run on the back end that are easier and they're better at object detection. Like Quen, I've heard is quite good. Vision language models, there's several. And it's only 4 billion parameters, but it does zero shot object detection. And so like there's woman and dog, and so it's gonna give it like simple object detection. Like we're not gonna get the leash or like her shirt. We're just gonna get woman and dog, I think. But I'm not totally sure. Let's see. There's, I mean, this is like, I mean, people want this for this exact reason, is like go around and make an inventory. But I'm pretty sure that, let's see, alignment evaluation, researchers and developers are free to use the code and model weights. We also allow their commercial use, check the license, so like we have to kind of figure out, okay, no license, so yeah, there's like captioning, text-based stuff, so it can recognize text sometimes. So if you've got like a cool ARM 5000 and a cool ARM 9000, it might be able to like tell the difference between them. So that's helpful. So we might be able to use another language model, another vision model, to do some of the work, or like some of the back end work.
I wonder too if AI might be able to recognize those sort of positional QR code things.
Yeah.
Like they like tell you like what your angle is to a surface based on how it looks. Because then you could just put a couple of those in the visual space and then it would know where it's at. Maybe not zero shot, but like
Figure out.
Because that's how cobots find their way in a physical space. They just use these kind of look like a QR that like it knows like how much skew it has. It's like, oh, I'm over here on that thing. That might be a well-calibrated optical thing, though.
No, but like first robotics does that all the time with cheap equipment, so there's probably like tons of documentation about it.
Yeah.
I'm pretty sure there's like in relation, relative position, representations, no. For vision, relative position encoding for vision transformer. Yeah, I wonder what that's called. I'm sure that's encoding relative positions with continuous augmented positional embeddings. What? Absolute or relative positional embeddings are the most popular ways to feed transformer models with positional information. Okay. I'm just looking for position tasks. Rotary position embedding. These are all about embeddings. Let's see. Like, I want to figure out how to do this. I've never done it before. You know what? You know who would know? It's ChatGPT. ChatGPT would know. Okay. Okay. How do I use several images to, or use the skew on a image of a QR code to figure out where I am in relation in terms of the angle to the QR code and algorithm to interpret the skew of an image of a QR code within a photo to tell where I am in relation to, in terms of the angle. I want to use this to triangulate my exact position in a warehouse by putting QR code images around. It will tell me. Okay, detect the QR code in the image. We don't need to read it. The bounding box, calculate the skew. The four corner points of the QR code, you can calculate the angles between the edges. Okay, this is the actual position. The skew and the dimensions in the image can be used to estimate your angle relative to the QR code. Okay. But like, is there some library or research about TV, QR, get perspective transform, warp perspective, visual fiducial system. Visual fiducial system. I have never heard that phrase before. Okay.
Fiducial.
April tag. Okay.
Oh, fiducial marker.
Popular in research. Alright, it's popular even.
I don't know what that means.
That literally means banana for scale. Like, it's like holding a thing that you know the known size of so that you can reference the something else.
It's literally banana for scale for robots.
Yeah.
Amazing. Alright.
Yeah.
Tag. You can find tag images for the pre-generated layouts here. Okay. Most recent version of April tag, which includes a detector, detection rate on small tags, flexible tag layouts, and pose estimation. Okay. So.
Wow. This is so cool.
Okay. That's true. Yeah. Detection distance, pose estimation. Info T struct using your known parameters. Okay. That's pose estimation. Okay. Yeah. Alright, so that's one thing. Z-bar. That's not what I want. Alright. Pose estimation. QR code-based mobile robot navigation system. Okay. That is basically what I wanted. Design of a WSN platform for long-term environmental monitoring for IoT applications. What? Alright. Oh. Alright. I want this, but yeah, Aruco markers. Okay.
Have we tried OpenCV?
Yeah. We
For the
have
video
OpenCV
capture?
up in here. Like, we're using that already.
Got it. Cool.
So it's very able to, in this process, in the like capturing of the frame, like we can, right now, all we're really doing is getting the image to OpenAI. But we could do a different thing. We could like do stuff with OpenCV to figure out where we're at. And that would go in the Orient phase of just like, where are we in relation to the things? That's what the Orient phase is for, really. So, okay. April tag 3 supports a wide variety of possible tag layouts in addition to the classic layout. It is also possible to define.
I fed the April tag site into ChatGPT, and I was like, how can I have you drive a Rover with this? And it came up with all of it.
Oh, great. Wonderful. There's just like an April tag website.
It said, yeah, here, let me drop it somewhere. I'll get back into Gather. It automatically said, just tell me when I see a tag in the frame, where do you want me to go? It was like, give it some simple logic.
Mm-hmm. Okay.
And it says ChatGPT can interpret the April tags in autonomous mode. So it'll like develop some memory of the tags, apparently.
Is that